Hello there everyone. In today's class I would like to talk to you about how to make a solution with a very specific molarity. So in chemistry we're always trying to make different types of solutions, and most solutions vary in their concentrations. So some might be stronger, some might be weaker. In order to make a solution with a very specific or exact concentration or molarity, we have to think about how much solute is added in with the solvent. Now, in this example here, we have two solutions. Okay, one is light blue, the other one is dark blue. You might say that the light blue is a little bit less concentrated, and the dark blue might be more concentrated. But suppose that you only had one of the vials or one of the containers here, and you weren't comparing it with another substance. Okay, so visually you won't be able to tell the difference between the two because you only have one of those beakers, or early minor flasks. So in this case, how can you determine whether your specific solution is strong or weak? How concentrated is it? Well, let's say in one of these two flasks, okay, we used 35 grams of copper chloride and 100 milliliters of water. Well, now that we have some values, can we actually say that this is a strong solution? Is it concentrated? Well, from what you guys know right now, the only thing that you can probably calculate is the substance's solubility. So if we take 35 grams divided by 100 milliliters of water, that will give you 0.35 grams per milliliter. But is this concentrated? Is this a lot of solute in solvent? One of the problems is we don't actually know what the actual solubility is. This value here just tells us how much solute is currently in solvent. So current solute in solvent. Is this a saturated solution? Is this currently unsaturated? That's the problem. If I add more solute to this 100 milliliters of water, will more dissolve? If it doesn't, then we've reached saturation. But is something that's saturated very strong? Okay, we have a lot of questions here because solubility alone cannot tell us how strong a solution is. So it cannot tell us how concentrated a solution is or even can be. Okay, in order to figure out the strength of a solution, we need to find its molarity. So just ignore this part here. Apologies, gotta get rid of this. Okay. So to find this, to find the strength of a solution, let's get back into writing mode. Okay. To find the strength of the solution, we need to find the substance's molarity. Molarity is just a fancy word of looking at how much solute is in solvent, but we're not looking at it from the perspective of grams. We're looking at it from the perspective of moles. So molarity is represented by capital M. And it is equal to the moles of solute over the volume of solvent in liters. Okay, and it's always in unit of liters, just as the solute right now is always in the unit of moles. So simply put, if you actually want a formula, molarity is N divided by V. So it does look very similar to your solubility formula, okay, except you're using moles instead of grams. But the number that you get actually has a different meaning. Okay, so if we take the example that we were given at the beginning, you have 35 grams of copper chloride. Okay, 35 grams doesn't tell us much. We have to convert to moles. So let's do that. So the molar mass of 1 mole of copper chloride is actually 134.45 grams. We've made this type of calculation many times before, so hopefully it stays in your head. And we figured out that this actually comes out to be 0.2 moles. Okay. Now let's keep this in mind. If this is moles, this is our N value. We need volume. And volume was basically 100 milliliters of water. But again, for molarity, everything has to be in liters. So using my conversion factor to change milliliters into liters, it's 1 liter over 1,000 milliliters. So milliliters cancel out, and basically you get 0.100 liters, which is your volume. So to find the molarity of the substance, I put it into the molarity formula. So it would be 0.26 moles over 0.100 liters, and that comes out to be 2.6 molarity of CuCl2. So molarity is capital M. Another way to write this, okay, that's also acceptable and sometimes used quite often. Instead of writing big M for molarity, you literally just keep with moles per liter of CuCl2. Okay, so either one of these formats is fine, 2.6 molarity or 2.6 moles per liter. They both mean the same thing. Now, here's the key to it. When we have the molarity, it actually does tell us more information than just the solubility alone, okay, or how much solute is dissolved in solvent. Okay, and this is the reasoning. A lot of things that are very concentrated, okay, they tend to have a concentration that is greater than 1.0 molarity. Okay, so anything that's 2.0 molarity, 3.0 molarity, okay, going in this direction as the number gets higher, it means more concentrated. if you go the opposite way, so let's say 0.1 molarity, 0.2 molarity, okay, etc., this becomes more dilute. Actually, let me change that value here to 0.01. Okay, that makes more sense. Okay. So when you get to these decimal values, the substance that you have is more dilute. When you go away from 1 molar, it's more concentrated. So 1.0 molarity is kind of our standard. Okay. Anything that's usually 1 molarity, depending on what it is, usually doesn't harm you or burn you. Okay, it's not corrosive. It basically just is a standard molarity that we can compare everything else to. So with our solution of copper chloride, it's at 2.6 molarity, which is right about there. So compared to standard, it is quite concentrated. Okay, so that solution that we've mixed up, okay, even though it looks like it has a very low solubility, when you actually make it into a solution, it is fairly concentrated. Okay, so we can use the same idea that we just learned. Okay, and if we wanted to make a solution with a specific molarity, what we need to do is we always need to calculate the amount of moles that are given in your desired volume. Once you have moles, convert to grams. So we're kind of doing things backwards now. Here, in the previous example, you had a certain amount of solute, and we had to find the concentration. But here, if I give you a concentration, let's say I want you to make a solution that has 1.5 molarity, okay, and I want the volume of that solution to be 100 mils. Well, you have to find the number of moles first. Okay, that number of moles has to be contained in this specific volume of 100 milliliters. So this is the best way to solve for this. Use the cross multiplication method. Okay, so what you're going to do is you're going to set up what this 1.5 molarity means. 1.5 molarity means you have 1.5 moles in 1 liter of solvent. Okay. Now, because we're using 100 milliliters, okay, the units have to match up. So 100 milliliters is the same thing as 0.100 liters. So I'm going to put that on this side, like this. So if I know that 1 liter contains 1.5 moles, how many moles are there in 0.100 liters? That is my x that I have to solve for. So I'm going to cross multiply. Okay. X times 1 equals 1.5 times 0.100. Okay. So when we do this, x is going to equal 0.15 moles. So what we're saying is, in 100 milliliters, there are 0.15 moles of copper chloride. So to figure out how much I need to weigh out, because you can't weigh out 0.15 moles. Our scales don't work that way. So that's why we need to convert back to grams, just so that you can get the right amount of copper chloride. So if we did that, we would take 1.5 moles and we multiply it by the molar mass of copper chloride. Okay, so copper chloride was 134.45 grams in 1 mole. Moles cancel out, and we are left with 20.7 grams. So 20.7 grams is what we need. So this is the amount to measure and use. So once you have the amount that you need, okay, this is your solute. You're going to measure out 20.17 grams, and you basically just follow the same procedures that you would for creating a solution, which we would hopefully have gone through with you at this point. Alright, so the next time I see you, hopefully you will get a chance to create a very specific concentration or molarity of solution. And you'll get to practice how to make a solution. All right, see you guys later.